So today's notes are solving systems of linear equations by elimination day 2. And hopefully you remember from day 1 that when we used elimination, we were looking for a variable that had matching coefficients but opposite signs. It's okay if you have the same sign, we can deal with that, but it's ideal to have opposite signs. So on 1a, our y's had the same coefficient but opposite signs. One was a positive 2 and one was a negative 2. And with b, our x's had the same coefficient but with opposite signs. So one was a positive 3x and one was a negative 3x. So because of that, we were able to add these equations together in order to eliminate those variables. So if you look closely at b, if I add the two equations together, 3x plus negative 3x would cancel out completely, and then I was able to solve for y. We're going to use that same strategy with day 2, but we're not going to be given matching coefficients this time. We'll have to create them. So example 1, solve the system of linear equations by elimination. So if you look at the first example, x minus 3y equals 24 and 3x plus y equals 12. So we're looking for matching coefficients with preferably opposite signs. So this coefficient on the x is a 1, so that doesn't match with the 3x. And the matching coefficients do have to be on the same variable. So 1 and 3x don't match, we can't eliminate the x's now. Negative 3y and positive 1y. This has a coefficient of negative 3. This has a coefficient of 1. So those don't match either. So as the equations are written right now, we can't eliminate either of variables by adding or subtracting the equations. We need to create matching coefficients, and we can do so by multiplying. So I can either take the first equation and I can multiply it by 3 to get this 1x to become a 3x and match with this 3x. Or I can take the second equation and multiply it by 3 to get this 1y to match with the negative 3y. Since it's ideal to have the same sign or the same coefficient but opposite signs, I'm going to change this 1y into a 3y so that it matches with the negative 3y since those are opposite signs. So I can't just change it. I have to make sure the equation stays the same value. So in order to do that, I'm going to take this whole second equation and multiply the whole thing by 3. Because if I do the same operation to every part of the equation, it doesn't change the actual value of the equation. So when we do that, we're going to distribute the 3 in. So 3 times 3x, that's 9x. And then 3 times 1y, that becomes positive 3y. And then 3 times 12, we have to go all the way across the equal sign, is 36. So now I have that positive 3y that matches with the negative 3y up here. So I'm just going to rewrite this first equation above this second equation. So x and then minus 3y equals 24. And be careful to keep all of the like terms and variables matched up. So now I have matching coefficients and opposite signs, so I can cancel out that y by adding both equations together. So x plus 9x is 10x. Negative 3y plus positive 3y cancels out because negative 3 plus positive 3 is 0. And then bring down the equal sign. 24 plus 36 is 60. So now my equation is 10x equals 60. We eliminated the y variable, so it's no longer there. So if I want to solve for x now, I can do so by canceling out this 10. So this is 10 times x. So to cancel out multiplying by 10, I'm going to have to divide both sides by 10. So 10 divided by 10 is 1. So that cancels out and I'm just left with 1x or just x. And then 60 divided by 10 is 6. So we end up with x equals 6. And then now that we know that x is 6, we can solve for y by substituting x equals 6 into the equation and simplifying. So it doesn't matter which equation you pick. You can pick one of the two original ones. I'm going to choose the second equation. Since it already has just one y there, it's going to be a little bit quicker to solve. So I'm going to rewrite that second equation up here. 3x plus y equals 12. And then since I'm saying that x is equal to 6, I'm going to take that 6 and I'm going to substitute it into this equation where x is. So if it's x equals 6, it has to go in for x. If we got y equals, it would go in for y. So instead of 3 times x, my equation is 3 times 6 plus y equals 12. And then now we're just going to simplify to solve for y. So I can simplify the left side by multiplying 3 times 6. That's 18. And then plus y equals 12. Everything else just comes down. And then now I have 18 plus y equals 12. So I want to undo adding 18 to y. So I'm going to subtract 18 from both sides. So 18 minus 18 cancels out at 0. I can bring down the y. And then 12 minus 18 is negative 6. So we end up with y equals negative 6. And then last thing that we just need to remember to do is write our final answer as a point. So x comma y would be 6 comma negative 6. And then for b, x plus 4y equals 22, and then the second equation is 4x plus y equals 13. So this coefficient on the x is 1, so 1x doesn't match with 4x. This coefficient on the y is 1 also, so 1y doesn't match with 4y. So we don't have matching coefficients again. Last time, to decide between the two, because I can see that with equation 1, if I multiply equation 1 by 4, this becomes a 4x and it matches with this 4x. But if I multiply the second equation by 4, this becomes a 4y and it matches with this 4y. So we have two options just like we did with example 1a. But with example 1a, we chose to eliminate the y's because they had different signs. But with b, all of them have the same sign. These are both positive, these are both positive. So there's two options here. We know that we're going to multiply a 4 throughout one of the equations to get matching coefficients. If you want this problem to become similar to this problem up here, where you have opposite signs and you can add the equation, you would have to multiply a negative number throughout one of the equations to change the signs. So if you want to add the two equations, you have to make sure the signs are opposite. We would have to multiply a negative throughout. I'm going to show you what you can do if you have the same signs and you don't want to multiply by a negative. We'll just have to subtract the two equations. So I'm going to take equation 2 and multiply it by 4. So I'm going to multiply a 4 throughout the entire second equation so that this 1y becomes a 4y and it matches with this 4y. So when we multiply a 4 throughout the entire equation, we're going to distribute it in. So when I distribute it in, 4 times 4x becomes 16x. 4 times y becomes 4y. And then 4 times 13 is 52, so equals 52. And then now this 4y matches with this 4y, so we can just rewrite this first equation over the top. So x and then plus 4y equals 22. And then up until this point with elimination, all of our examples have had opposite signs over the coefficients that match. So when they've had opposite signs, we've added the two equations together. And that's because if we pretend in our head that these were opposite signs, if I had negative 4 plus positive 4, those would cancel out. But if I add these two equations together, these actual equations, it would be 4 plus 4, like positive 4 plus positive 4, which is 8. So I can't actually eliminate y by adding the two equations together. I have to subtract the two equations because 4y minus 4y now would cancel out because they're the same sign. So I just have to make sure that I actually do subtract all three terms on the bottom. Sometimes it's easy to forget a term, just be very careful to subtract all of them. So x minus 16x. That's like 1x minus 16x. So 1 minus 16 is negative 15x. And then 4y minus 4y, or 4y minus positive 4y, that's 0. It's just 4 minus 4, so it cancels out. And then equals, and we're still subtracting, so 22 minus 52, that's negative 30. Now I have negative 15x equals negative 30. The y got eliminated, so I want to solve for x. So I can get x by itself, or I can isolate x by canceling out multiplying by negative 15. So to cancel out multiplying by negative 15, I'm going to divide both sides by negative 15. So negative 15 divided by negative 15 cancels out. I'm just left with x equals, and then negative 30 divided by negative 15 is positive 2. And then now I know what x is, so in order to solve for y, I'm going to have to take my x equals 2 and substitute it into one of the original equations. Doesn't matter which one, whichever one you think is easier for you. I'm going to use the second equation, so I'll rewrite it over here. For x and then plus y equals 13. So just rewritten up here, 4x plus y equals 13. I'm saying that x equals 2. So that 2 is going to go into that equation where x is. So instead of 4 times x, it starts off 4 times 2. And then everything else comes down, plus y equals 13. And now we need to simplify to solve for y. So I can simplify by multiplying 4 times 2, that's 8, plus y equals 13. And then I want to get y by itself, so I have to undo adding 8. I can undo adding 8 by subtracting 8 from both sides. And then 8 minus 8, that cancels out. I'm going to bring down the y. And then 13 minus 8, that's 5. So now that we have both variables solved for, we have our final answer. Just have to write it as a point, x comma y, so 2 comma 5.